Hello guys, welcome to my YouTube channel. So in this video we are going to look at science paper 1 section B prediction 2023. So this one is not a leakage but a prediction. This one is not a leakage but a prediction. So if you are new to this channel, kindly subscribe for more videos. So the questions that are likely to come in your paper, the first one is length and time. Now under length and time, you need to know how to measure objects using the micrometer screw gauge, and also how to measure objects using a vernier calipers, and also the objects that a micrometer screw gauge measures, and also the objects that a micrometer screw gauge and a vernier calipers measures. Apart from that one, you need to know how to measure the time using the simple pendulum. You need to know how to measure the time using the simple pendulum. Okay, apart from that one, you need also to know the terms which are used under simple pendulum. So the first one being is the period of the pendulum, the time taken for the number of oscillation to be made, the time taken for the number of oscillation to be made. Okay, apart from the period of the simple pendulum, you need also to know the oscillation, the complete swing or revolution of a pendulum bob, oscillation, the complete swing or revolution of a pendulum bob. Apart from that one, we also have the frequency. So the frequency is the number of oscillation made in 1 second, the number of oscillation made in 1 second. Apart from that one, you need to know the factors that affect the period of the pendulum, the factors that affect the period of the pendulum, and the factors that does not affect the period of the pendulum. So the first one on the factors that affect the period of the pendulum is the first one is the acceleration due to gravity. The acceleration due to gravity affects the period of the pendulum. Apart from that one, we have the length of the string. So the length of the string is affects the period of the pendulum. So when you increase the length of the length of the string, you are going to find that there will be reduction in the number of oscillation. But if you reduce the length of the string, there will be more oscillation to be made. Okay, then the factors that does not affect the period of the pendulum, we have the first one, which is the mass of the bob, followed by the amplitude. So I'm saying on the factors that does not affect this the simple pendulum, we have the mass of the bob and also the amplitude. Okay, so on this part here, you need to know the factors that affect the period of the pendulum. Okay, apart from that one, you need to know how to take readings when measuring an object using the vernier calipers and also the micrometer screw gauge. Okay, so now on the vernier calipers, the formula for finding the final reading is like this: the main scale plus the vernier scale multiplied by the accuracy is equal to final reading. Okay, so what is important here is for you to know the accuracy of the micrometer screw gauge and also to know the accuracy of the vernier calipers. So let me start with the vernier calipers. So the accuracy of the vernier calipers in centimeters, it is 0.01 centimeters. It is 0.01 centimeters. Then as for the accuracy of the vernier calipers in millimeters, it is 0.1 millimeters. 0.1 millimeters. Okay, so how we take the readings from the vernier calipers is like this. So we have the main scale and also the vernier scale. So on the vernier scale here we have the 0 here. As you can see, we have the 0 from the vernier scale. So now on the main scale, we take the reading. We take the reading before the 0 on the vernier scale. Before the 0 on the vernier scale, which is this one here. Okay, so I'm saying on the main scale, we take the reading before the 0 on the Vernier scale. Okay, then on the Vernier scale, we take the reading where two lines are colliding, from the main scale and also from the Vernier scale, where two lines are meeting or colliding. Okay, so in this case, as for the Vernier scale, here we can count from 0. Then I can say 1, 2, 3, 4. So my Vernier scale is going to be 4. Okay. So now, as for the simple pendulum, sometimes they can give you the time. Always they can give you the time, and then they can't give you the number of oscillation. Now, it is very easy for you to find the number of oscillation. So now, in finding the number of oscillation here, we can use probability. So when the bulb moves from A to B, and also it can also move from B up to C, and also it can move from C up to B and back to A. When a bulb moves from A to C and back to A, it is going to make one complete oscillation. Okay. So now on this part here, if they ask you to find the number of oscillations, since here we have 4 moves, from A up to B we have 1 move, from B up to C we have 2 moves, from C up to B, from C back to B we have 3 moves, from B back to A we have 4 moves. So here you can say, if we are to find the number of oscillation from A up to B, we are going to say 1 over 4, which is the total probability. 1 is the favorable outcome and 4 is the total probability. Then the answer of the number of oscillation is going to be 0.25. Okay. Then apart from that one, you need to know the correct formula for calculating the period of the pendulum, which is period of the pendulum is equal to time taken over number of oscillation. So as for the period of the pendulum is measured in seconds. Okay, so you need to put correct unit. Apart from that one, you need to know the formula of the frequency. So frequency is equal to 1 over the period of the pendulum. Okay, so let's move on to the next one, which is the waves. Okay, so now under waves here, you need to know the types of waves. So now, under types of waves, we have 2 types of waves. We have the longitudinal wave and also all longitudinal waves. So an example of a longitudinal wave, it is a sound wave. Okay, and we have the transverse wave. Examples of a transverse wave or waves are all electromagnetic spectrum or electromagnetic waves, like radio wave, ultraviolet, infrared, those things. Okay, so in an example they can say differentiate between sound wave and ultraviolet. Then you are going to say sound wave is a longitudinal wave, while ultraviolet is the transverse wave. Okay, so now on this part here, you need to know examples of electromagnetic waves. So now, for us to know the electromagnetic waves, we are going to use the mnemonic, which goes like this: my lost means is very unusual Xmas gift. So I'm saying my lost means is very unusual Xmas gift. Now, as for lost here, I'm going to use ARA. For a special reason, where ARA is going to represent radio wave. Then as for mains, M is going to represent microwave. Then as for is, I is going to represent infrared. Then as for V, which is V is going to represent visible light. Okay. Then as for unusual, which is U, is going to represent ultraviolet. Okay. Then as for Xmas is going to represent X-ray or X-rays. Then the last one, which is gift, is going to represent gamma ray or Y rays. Okay, so gamma rays or Y rays. Then apart from that one, you need to know the speed of all electromagnetic spectrum. So all electromagnetic spectrum, they have a speed of 3 3.0 multiplied by 10 to the power 8 meters per second. So I'm saying all electromagnetic spectrum or all electromagnetic wave, they have a speed of 3.0 multiplied by 10 to the power 8 meters per second. Then apart from that one, you need to also to know how to calculate speed or velocity, how to calculate the velocity of different electromagnetic spectrum using this formula E, which is velocity is equal to frequency multiplied by wavelength, which is the lambda, okay, which is the lambda. So now on this part E, wavelength should be measured in meters. Then as for the frequency should be measured in hertz, and speed, or which is the velocity, should be measured in meters per second. Okay. Apart from that one, you need to know the properties of all electromagnetic spectrum. The first one, you can talk of the formula. All electromagnetic spectrum, they obey to the same formula, which is velocity is equal to frequency multiplied by wavelength. Apart from that one, you talk of speed. The speed of 3.0 multiplied by 10 to the power 8. Okay. And apart from that one, you can also say all electromagnetic spectrum are transverse in nature. All electromagnetic spectrum are transverse waves in nature. Okay, so the next topic which is likely to come in your paper is moment of a force or moment. So on this part here, you need to know how to define what moment is. You need to know how to define what moment is. Okay. Apart from that one, you need to state what principle of moment is. So as for the principle of moment, said that for a body to be in equilibrium, the sum of clockwise moment is equal to the sum of anticlockwise moment about the pivot. Okay, so I'm saying for the body in equilibrium, the sum of clockwise moment is equal to the sum of anticlockwise moment at the pivot. Okay. Apart from that one, you need to know the formula for finding the moment. So the formula for finding moment is so here I've made a mistake. Instead of writing M, you need to put let me say instead of putting M here, I've put F. So you need to put M here. Okay. So moment is equal to force multiplied by distance, where distance should be measured in meters and force should be measured in newtons. Okay. So now you know that sometimes they can draw a seesaw and then they are going to give you different information like mass. If they give you mass E, since you know that force is equal to mass multiplied by gravity, so in the place of force E, you can put mg to represent the force. So I'm saying if they give you mass to calculate the moment, you are going to put mg, which is representing the what? The force. Okay. Apart from that one, you need also to know the factors which are required for a body to be in equilibrium, or the factors that affect stability, like the center of mass and also the base area of an object. So the first one is the center of mass or gravity, and then the base area of an object. And then the last one, the clockwise moment should be equal to what? And clockwise moment for the body to be balanced. Apart from that one, you need to know the application of moment, like seesaw, doors and windows. So we can use or we can apply the moment using a seesaw, or when turning a spanner, okay, or when opening a door. Okay. Apart from that one, we also have another topic which is likely to come in your paper, which is radioactivity. So on this part of radioactivity, you are going to find it on question B9. Okay, on question B9, and also waves, you are going to find them on question B5. Okay, so now under radioactivity, you need to know how to define radioactivity and half-life. You need to know how to define radioactivity and the half-life. Apart from that one, you need to know different types of radiations, like the alpha radiation, beta radiation, and also gamma radiation or Y-ray radiation. Apart from that one, you need to know the properties of different types of radiation, like alpha particle. So as for the alpha particle, it is positively charged in nature. As for the alpha particle, it is positively charged in nature. Okay, apart from being positively charged in nature, the alpha particle has the nature to that of helium. The alpha particle has the nature to that of helium. Apart from that one, the alpha particle can be affected by both the magnetic field and electric field. So I'm saying an alpha particle can be affected by magnetic field and electric field. So let's move on to the next one, which is a beta particle. So as for the beta particle is negatively charged in nature. Beta particle is negatively charged in nature. As the result, when it passes through the electric field, we are going to find that it is going to bend toward positive charges. Since unlikely poles they are going to attract. And beta particle is negatively charged in nature, which means it is going to bend toward negative charges or negative streams. Okay. Apart from that one, we can say the beta particle, it has the nature to that of helium. Let me say to that of electron or of an electron. So as for the beta particle, it has a nature to that of an electron. The beta particle, it has a nature to that of electron. So a beta particle is also affected by both electric field and the magnetic field. Then the last one is gamma or Rayleigh. This one here, it can't be affected by magnetic field and electric field. So this one here travels in a straight line. Gamma ray travels in a straight line, okay, and it is neutral. It doesn't have a charge. So its charge is neutral, or you can say zero charge. Okay. Apart from that one, you need to know the decaying equations. You need to know the decaying equations of an alpha. So the decaying of an alpha, let's say for example, if X here it is the element. So as for A is representing the mass number or the nucleon number. So in an exam they can say define nucleon number. So the nucleon number, it is the total number of protons and neutrons in the nucleus of an atom. So the total number of protons and the neutrons in the nucleus of an atom. So as for the alpha decay, the mass number is going to remove 4, which is the mass number of helium. Okay, so the mass number will subtract 4. Okay, then also the proton number or the atomic number will subtract 2, which is the electron number of helium. Okay, so let's say for example, if this one here this one is uranium, which is 235. So if uranium undergo alpha decay, we are going to find that the new mass number of the daughter nuclide is going to be 231. Since here we have 235, so on the mass number here we can have 231. Okay, then on the proton number or the atomic number of the nuclide, we are going to have 90. Okay, since here we can say 92 minus 2, we are going to have 90 here. Okay, so apart from that one, you need to know the beta decay. Okay, so when an element or an isotope undergoes a beta decay, the mass number will be added by 0 and the proton number will be added by 1. And for the gamma decay, you're going to find that nothing is going to change. The mass number is going to be added by 0 and the proton number here is going to be added by 0. As the result, the mass number is going to remain constant and also the proton number is going to remain constant. Apart from that one, you need to know the examples of or the types of nuclear reaction, like fission reaction and also fusion reaction. So as for the fission reaction, this is the splitting up of unstable nucleus to form light nuclei. The splitting up of the parent nuclide to form light nuclei. Then as for fusion reaction involves the joining of light nuclei to form a big nuclei, or we can say the parent nuclei. Apart from that one, need to know the examples of nuclear fission. An example of a nuclear fission reaction, For example, when uranium undergoes nuclear fission, two products are going to be produced. That is barium and krypton. That is barium and krypton. Then as for nuclear fusion, you're going to find that once an element undergoes nuclear fusion, you're going to find that hydrogen 2 is going to react with hydrogen 3 to produce helium plus neutron plus energy. So on that part, you can also look at the background radiation and so on. So the definition of background radiation, so those things are very, very important. And also methods of detecting radiations. Method of detecting radiation, like using a GM tube. By using a GM tube. Apart from GM tube, you can also use scintillation counter to detect radiations. Apart from that one, you can use also the cloud bulb chamber, okay, to detect radiations. Apart from that one, you can also use the photographic plates or fumes. Okay, so apart from that one, you need also to know the safety precautions that you need to take when handling or storing radioactive elements, like wearing goggles, wearing gloves. Apart from that one, you need also to know that when handling the radioactive materials, you need to wear a lead shield. Okay, why are we wearing the lead shield here? When you talk of the ionization, when you talk of ionization and penetration of these different types of radiations, you're going to find that alpha radiation has the high ionization. Okay, so as for ionization is the ability of an element to form a cation or an ion. Okay, so as for an alpha radiation, it has the high ionization, followed by the beta radiation. Then lastly, we have gamma radiation. So in terms of ionization, gamma is the last one. Then in terms of penetration, gamma rays or gamma radiation, it has high penetration. Gamma ray, it has the high penetration, followed by the beta radiation, and then lastly we have alpha radiation. So a gamma radiation can be stopped by a sheet of lead. So a gamma radiation can be stopped by a sheet of lead. Then as for the beta radiation, this one can be stopped by a sheet of